Yeah, good evening everyone. Good evening. Good evening. Yeah, good evening everyone. Good evening. Good evening. Comment one time good evening so that we can start the class. Comment one time good evening so that we can start the class. Can we start? Can we start now? Yeah, let's start. Hi Shashank. Hi Shashank. Hi Shashank. Yeah, I'm starting now. I'm starting today's class. I'm starting today's class. So let me write here. I'm writing here. Today's class, I think 9th, I think so. 9th or 8th. 8, 8, 25. Yeah, good evening, Mohit. Good evening. 8, 8, 25. Right? Today's date is 8, 8, 25. We can start now. We can start. So, lexical analyzer starting. Lexical analyzer. Lexical analyzer chapter is starting. I think we can start now. So 8, 8, 25 lexical analyzer. I'm starting, right? So I'm giving signal also 1, 2, 3. 8, 8, 25 lexical analyzer. I'm starting, right? So you can write now. You can write now. Lexical analyzer. Lexical analyzer. Lexical analyzer is first phase of the lexical analyzer is first phase of the compiler. Lexical analyzer is first phase of the compiler. which is also known as scanner. Lexical analyzer is the first phase of the compiler, which is also known as scanner. That is the first point. Second point, it divides the program into meaningful words. Which are known as tokens. You know very well lexical analyzer purpose is tokens. It divides the given program into meaningful words, which are known as tokens. Yeah, so please careful till now. Which are known as tokens. Lexical analyzer is the first phase of the compiler. Which is also known as scanner. It divides the given program into meaningful words, which are known as tokens. So careful everyone until here. Lexical analyzer is the first phase of the compiler, which is also known as scanner. It divides the given program into meaningful words, which are known as tokens. Everyone know this. So remember everyone. Lexical analyzer chapter starting now. It is the first chapter. Lexical analyzer is the first chapter. It is the first chapter. Right? If anyone is not okay with the previous classes, please go back once and revise. You are not okay with the previous classes, please go back and revise. Nothing there here, nothing. See, I'm not creating some wonders here, right? So normal things. One time if you listen, you will get the clarity. Lexical analyzer is the first chapter. I'm starting. Anyone having any doubt with the previous classes, please go to previous class and check. Please go to previous classes, whatever is there. Almost 4 classes item. You can go through all the 4 classes one time and you can check. Right? In my opinion, in the compiler, it is the first class. In my opinion, in the compiler, it is the first class. If you see from here onwards, you will get the full marks. I'm repeating once again, right? Compiler starting now, from now onwards, if you follow, you will get the full marks. So, however, previous things, if you have any doubt, just revise one time. Previous things, you have some small doubt, revise once. So I started now, I started. Lexical analyzer is the first phase of the compiler, which is also known as scanner. It divides the given program into meaningful words, which are known as tokens. I think until now, everyone is fine. Can you take this diagram? Careful. Can you take this diagram? Lexical analyzer. One nice diagram is there. Can you take this one? Lexical analyzer. Parser. Lexical analyzer, parser. Parser means syntax analyzer. Syntax analyzer, another name is parser. Lexical analyzer, another name is scanner. Right? Syntax analyzer, another name is parser. Try to understand. Lexical analyzer, there is a parser. So see this diagram. Lexical parser is asking, I want next token. Parser is asking, I want next token. Parser asking the lexical analyzer, I want next token. Whenever you will ask next token, lexical analyzer will create the token and it will send that token to parser. Right? Lexical analyzer will create the token. Right? It will create the token and it will send it. So send the token. Lexical analyzer and parser. Parser will ask the lexical analyzer, I want next token. So lexical analyzer will send it. Lexical analyzer will send it. So just token is send it. Now next one. While doing the story at any point of time, lexical analyzer want to store or want to take from symbol table, it can take. Symbol table. Parser also can take, can store, can take also. What is the meaning of this diagram? You will get to know. What is the meaning of this diagram? You will get to know within few minutes. Parser will ask the lexical analyzer, please give token. Lexical analyzer will create the token and it will send the token to parser. Parser will use it. While doing the story at any point of time, lexical analyzer or parser want to store, they can store in symbol table. Right? So if they want to take from symbol table, they can take also. They want to store, they can store in symbol table. If they want to take, they will take from the symbol table. Okay, fine. So I think until now you may not get also. Within few minutes, everything all right. Remember, compiler started just now. This is the only thing which happened in the compiler till now. Previous classes you are not okay, then also no problem. Previous classes you are not okay, then also no problem. But however, safe side. One time go back and one time see. Safe side, one time go back and one time see. But to be frank, compiler started now. Lexical analyzer, right? It is the first phase of the compiler known as scanner. It divides the given program into meaningful words which are known as tokens. So parser will ask the lexical analyzer, I want a next token. Lexical analyzer will do some work and it will give that token to parser. While doing the story at any point of time, anything they want to store or they want to take, they can take from symbol table. Okay, fine. That is okay. Now you will get the clarity within few minutes. Careful, you will get the clarity within few minutes. Now I am giving one example. This example will solve most of the problems. This example will solve most of the problems. I am writing that example. Take this. Find number of tokens. Find number of tokens present. Find number of tokens present in the following program. In the following C program. In the following C program. Find number of tokens present in the following C program. Right? Yeah, I think until now it's okay. Now I will give the program. Careful, no need to confuse. Int main finding bigger number between A and B. Finding bigger number between A and B. Right? It's a comment. Everyone knows it's a comment. Now see this one. Int A value 25, B value 45. Next one, if A less than B, return B, else return A. End of this. Finding bigger number between A and B. Find larger number between A and B. Yeah, if you want, I can write like that also. Find large number. Find larger number between A and B. Now, this is the program. Please check yourself how many tokens possible. I will explain within few minutes. I will explain within few minutes. Can you write your opinion? Can you write your opinion? Within few minutes, I will explain. In this program, how many tokens are there? Find the number of tokens present in the following C program. Find number of tokens present in the following C program. So int main, find larger number between A and B. Right? Int A is equal to 25, B is equal to 45. If A less than B, return B. Else return A. I want answer from all of you. Right? How many tokens are there in this program? Can you find out? How many tokens are there in this program? Can you find out? Go ahead, everyone. Go ahead, everyone. How many tokens are there in this program? Mostly you can easily find out. You can easily find out. Please check once. I will help you within few minutes. I will help you within few minutes. Please check how many tokens are there. Your answer may be wrong, may be right also. As a CSE person, you can easily say how many tokens are there. As a CSE person, you can easily say how many tokens are there. If you do wrong also, no problem. If you do wrong also, no problem. I will take care. I will take care. Within few minutes, I will explain. Can you check yourself, everyone? Rohit, nice to have a good mentor like you, bro. Thank you, Rohit. Thank you so much. Can you go ahead once? In this program, how many tokens are there? A25, B45. If A less than B, return B. Else return A. Everyone. Ella said that 30. Ella said 30. Mohit, how many? Mohit, how many? Ella said 30. Mohit, how many? Kittu, how many? Where is Kittu? Are Kittu, where are you? Are Kittu, one day coming, one day not coming. Kya yaar? Kittu, kya man? One day coming, one day not coming. Are you there now? Kittu, are you there? So 51. Ella saying 30, Mohit saying 51. How that much big difference, yeah? How that much big difference? Find number of tokens present in the following C program. Int main, int A is equal to 25, B is equal to 45. If A less than B, return B, else return A. How many tokens? One saying 30, another saying 51. How we are? How it is possible? Ella, how it is possible? Almost double. Mohit, almost you are saying double. Ella, almost you are saying half. Ella, you are saying half. He is saying double. How it is possible? Check once. Hello. Yeah, let me give answer. Yeah, I will try now. I will try. Careful, everyone. I'm trying. Everyone listen. I'm trying this. Everyone listen. I'm trying this. Everyone. Everyone listen. See this one. So, counting tokens. Counting tokens is our goal. Everyone have to observe. Counting tokens is our goal. See how it's going on. It is a start state. Counting tokens is our goal. It is the starting state. It is the starting state. Now listen. On the starting state, careful. On the starting state, right? If you see the program, everyone observe. On the starting state, if you see the program, first character. Initially, lexical analyzer at the first character. Lexical analyzer at the first character. Lexical analyzer goal is tokens. Is the first phase of the compiler. Is there in the program first place. So on the starting state, we got I. Whenever on the starting state you got I, let's go to S1 state. S1 state means I is completed. S1 state means I completed. S1 state means I completed. On the starting state, I give an I as input. It will goes to S1. S1 means I completed. S1 means I completed. Remember everyone. So S1 means I completed because this is the automata. This is the finite automata, right? In the automata, purpose of every state is remembering something. So right, listen, to count the tokens, to divide the program into tokens, we are using finite automata. Finite automata means regular expression. Regular expression means pattern matching. I'm repeating once again. Right? So dividing the given program into tokens, we are using finite automata. Finite automata means regular expression. Regular expression means pattern matching. Some pattern means we are recognizing the pattern. Which pattern it is? On the starting state, right? I came. Just we are checking which pattern it is. So on the SO, I came. I will go to S1. Remember, S1 means I over. Now understand. C compiler will think like this one. Oh, only I over. In the C programming, starting with I, what can be? S1 state means I over. C compiler is thinking like this one. So programmer is user is written one program. In that first character is I. In the C programming, starting I, what can be? Oh, it may be into. It may be if. So S1 means I over. S means nothing over. S1 means I over. Purpose of every state is remembering something. In the automata, every state will remember something. Purpose of state is remembering something. On S, I came. I will go to S1. Now, can you see this one? On S1, it is expecting like this one. Okay, because of the C programming, I over. It may be if. It may be int also. So, on the S1 means I over. He is thinking that it may be if, it may be into. So, as usual, after I, if you see the program, N came. Then it will go to S2. S2 means IN completed. S2 means IN completed. Remember in the automata, finite automata is nothing but a collection of states. Finite automata is nothing but a collection of states. So every circle is state. So yes, right, initial state means nothing, remember. S1 state means I over. S2 state means IN over. Purpose of every state is remembering something. Purpose of S2 is IN over. Purpose of S1 is I over. And if you go to the big building, there are so many lifts are there. Right? Every floor one stage. Ground floor one stage. First floor one stage. Second floor one stage. Whenever lift is there in the second floor, it remember ground floor is over, first floor also over. Now you are in the second floor. Right? If the lift is there in the 10th floor, so state number may be S10. S10 means ground floor over, first floor over, second floor over. What I mean to say is every state will remember something. S is remembering, right? S is remembering nothing because it is starting. S1 is remembering I over. S2 remember, right? IN over. Purpose of state is remembering something. You may say that why starting state is not remembering anything. You may say that it is something like small kid. One kid is came now only on this earth. What he will remember? Nothing. Starting state is nothing, but one kid came now only. Just he came out. From mama's stomach, he just came out. Until now, he is there in the mama's stomach, right? right? Until now, he is there in the mama's stomach, just he came out. As soon as he came out, you don't remember anything. So SE is nothing but starting state. Starting state means nothing remembered. Nothing happened till now. S1 means I over. S2 means IN over. Now C compiler is thinking like this one. Oh, S2 means IN over. In the C language, starting with IN, what can be? C compiler knows very well about C language. C compiler knows very well about C language rules. So S2 means IN over. C compiler thinking like this one. IN followed by, in C language, what can be? I think they got to know. I think T possible. INT. INT. Now let's see this one. S3 means INT over. Please help me. Can I stop here? Can I stop here and confirm I got one token into, or can I proceed further? Please, can anyone guess? Should I stop here and confirm one token I got into, or should I continue further? Any hope there, I will continue. Any hope is there, I will continue. If hope is not there, I can stop. Can anyone help me? Should I stop and confirm I got token into, or should I continue? Hope is there, I will continue further. Hope is there, I will continue further. It is a very, very important statement. It is a very, very important statement. It is a very, very important statement. Please help me. On S3 state means INT over. Should I stop and confirm INT? It means one token I got. Should I stop and confirm one token came, or should I continue further? I am at S3. S3 means into over. Should I stop and say I got token into, or should I continue further? This is the very, very tricky thing. Please help me, everyone. Should I stop and confirm I got token into, or should I continue further? This is the very, very important statement. Total lexical analyzer is based on this statement only. Lexical analyzer is based on this statement only. Should I stop here and confirm I got token into, or should I continue further? Here token confirmed or not confirmed? Here token confirmed or not confirmed? Hello? Here token confirmed or not confirmed? Just I want to ask you one small line. Here token confirmed or not confirmed? If not confirmed, I will proceed further. If not confirmed, I will proceed further. If confirmed, I will stop. Token confirmed or not confirmed? If confirmed, stop and print it. If confirmed, stop and print. If not confirmed, continue. So till now, listen, till now, I read until here. See this one. Till now, I read here. See this one. Till now, I read here. See this one. This is over, this is over, this is over. Until now, I read 3 characters. I got to know already int came. Right? So token already confirmed. Should I go further? Doubt there, I will go further. Doubt not there, I will stop. Doubt there, I will go further. Until now, int only over. If you confirm it is a token, if it is a confirm, it is a token, I will take it. If not confirmed, I will go further. Should I go further, or is it confirmed? Should I go further, or is it confirmed? Another way of saying confirmed or not confirmed. Here token confirmed or not confirmed. One more time I am asking. Here token confirmed or not confirmed. Everyone, not only watching, please give answer. Here token confirmed or not confirmed? Everyone. Token confirmed or not confirmed? Bolo yaar. Bol do. Your token confirmed or not confirmed? If not confirmed, I will continue further. Confirmed, I will stop. Hello. If confirmed, I will stop. If not confirmed, I will continue. Last time I'm asking. Last time I am asking, is it confirmed or not confirmed? Yeah, I will give the answer. Everyone listen. It is a confirmed or not confirmed, I am asking. All the people are saying confirmed. Remember, not confirmed. Remember, not confirmed. The reason is this one. The reason is I am giving the answer. Not confirmed. Not confirmed. The reason is this one. The reason is you may be thinking, int is a one token of keyword type. You may be thinking that int is a one token of keyword type. You may be thinking like that. You may be thinking, understand one thing. Some people are saying that int is over, int is a one token. You may be thinking like this. You may be thinking. But remember, there may be a chance that, right, int a, variable name may be int a. Variable name may be int a. There are some mental people are there who will declare a variable name as int a. Variable name as int ab. Variable name as int abc. Variable means what I mean to say is starting with the into need not be keyword. Int followed by a, it's a variable name. Next one, int followed by abc. It's a variable name. There may be. So doubt is there, continue. Int ab, there may be a function also. See, I can keep name whatever I like. Variable name, function name, I can keep whatever I want. Remember, you may be thinking, so int keyword, but there may be variable also, int ab. If I continue further, variable name may be int ab. So what I mean to say is a very important line. Tokenization is going on. Just to take care one important thing. What is the answer? Longest matching. Not only matching, longest matching. Not matching, longest matching. Tokenization means longest matching. Some people may say that, sir, int matching, na? Int matching. Then what is the problem? Int matching, but int AB also matching. Int A also matching. Int ABC also matching. Sir, these many matching. Longest matching I want. Tokenization means longest matching. Tokenization means longest matching. Try to understand. Tokenization means longest matching. If anyone say what is tokenization, simply say longest matching. Not matching, longest matching. If anyone say simply matching, see this one, int. If anyone says simply matching, int, I is a one variable name, n is a one variable name, T is a one variable name. Remember, individually matching. See this one, individually matching, combinedly also matching. Then take combinedly, don't take individual. Individually, see, only I variable, only n variable, only T variable. Combinedly also token. Individually token, combinedly also token. See, individually I token, n token, T token. If I combine it into also token. So you may say that, sir, combinedly into which type of token? Keyword type token. Individually, if you observe, what is the answer? I is a variable name, means identifier type token. N is a identifier type token. T is a identifier type token. So individually tokens, combinedly also token of keyword type. So final thing is tokenization means longest matching. Now it is the correct time to ask you. Please give answer now. You confirm now or dilemma? I am at S3 means into over. you conformed, or dilemma. Because I want longest matching. I want longest matching. See, tokenization means not matching, longest matching. Tokenization means not matching, longest matching. See, I is a variable name. N is a variable name. T also variable name. Individually variable names. Individually tokens. Combined also token. Then take combined. Individually token. Combined also token. Then take combined. Then take combined. Try to understand. Try to understand. Can you help me now? Now, int is a token or doubt there? Int is a token or doubt there? Please give answer. Int is a token or doubt there? Int is a token or doubt there? Okay, don't respond. Don't respond. Don't respond. Int is a token or doubt there? Array, longest matching, na? Yeah, sorry, doubt. Yeah. So longest matching. So we have to see further. We have to see further. Until now, I didn't get a confirmation because int followed by a may be there. Int a. Variable name is int a. Of course. See, I cannot write the variable name as into. I can write int a. Variable name, I cannot write only into. Int a I can write. Float b I can write variable name. So doubt is there. If doubt is there, continue further. If doubt there, continue further. I'm continuing. See this one, I'm continuing. So until now, 3 characters I read. See, I read, N read, T read. See, next character. Can you see the next character? Everyone observe, next character is blank. Can everyone see this? Can everyone see this one? Next character blank. Next character blank means it is a confirmed. Next character blank means it is a confirmed. See this one? int already, listen, int already token, but I want longest matching. I read further, gap is there. If gap is there, right, remember, int gap cannot be a token. So only int. So I thought that int followed by something there. So there may be a chance that a variable name, int ab, variable name may be int ab. So I thought it is a variable name. I continued further, but I got gap. So that gap indication that, see this one, combinedly not token, then until int only token. See, I tried for longest, right? Int only longest, because further gap is coming. So what you do is, listen, token found. This means token found, which is nothing but final state. Token found, which is nothing but a double circle. Token found. Some people are asking, sir, what is that token? See this one, token found, that's okay. What is the token? Until now, int over. Int followed by gap. Don't conclude gap. Don't add the gap here. So whenever you find out longest matching happened. So token is found. That token is int only, which type? Keyword type. Remember, to confirm the token, I may read more character. To confirm the token, I may read more characters. See, I read one character. By seeing the character blank, I got to know int is a token. So token found means final state. Token found, final state, right? Then, and which type of, what is the token? Token is int. Int followed by gap cannot be a token. Combinedly not token. So I will go one position back. I may read extra. If possible, extra thing I will add. If not required, I don't add. See, I read int. Int already over. Int followed by gap also I read. I thought this gap will be useful. If useful, I will add it. If not useful, I will delete it. So I don't take it. I read already, but it's not useful. Simply ignore. Last character what you read. If useful, use here. If not useful, simply ignore. In this token, simply ignore. Because it is a gap. So next one, int is a token. I find out which type of token. Not only saying token, you have to say which type of token. It is a keyword type token. So one token is found out. Listen, until here over. You read the program until here. You read the program until here. You got the final state. You got token. Token is into, which is the keyword. Everything fine. Now next token starting. Remember, total program you have to divide into tokens. Total program you have to divide into token. One token over. Now from the next character onwards, again starting state. See, from the next character onwards, because one token already find out. You are trying for next token in the program. Read the next character M. Remember, from the starting state, every possibility there. I also there, M also there. Now see the answer. M is came. Remember this state indication that M is completed. This state indication that M is completed. On the state A also came. This state indication that MA over. Right? On the state I also came. This state indication that MAI over. Right? On the state N came. This state indication that MAIN over. Please help me. I am at this state. Token confirm or dilemma. Because I want longest matching. I want longest matching. Token confirmed or dilemma. Now I am at this state. Now I am at this state. Now I am at this state. At this state, token MAIN over. Now I am at this state. MAIN over. Token found or dilemma. If dilemma, you have to read. If no dilemma, you can confirm. After every token, come back to starting state. After every token, come back to starting state because you have to try for next token. From next character onwards, try for next token. From next character onwards, try for next token. Can you say dilemma is there? Read further. Dilemma not there. Stop and say token. I am expecting answer from all of you. Dilemma there or not there? I am expecting from all of you. Dilemma there or not there? Say dilemma there. Dilemma there. Some people are asking dilemma there. What dilemma you have? Ella, please let me know. You are saying dilemma. What dilemma? Mohit, what dilemma? Ella, what dilemma you have? Mohit, what dilemma you have? Let me know. Let me know. What dilemma you have? Everyone have to say to me, I want longest matching. I want longest matching. Are you trusting? MAIN is longest matching. I want longest matching. Do you think MAIN is longest matching? I want longest matching. MAIN is longest matching. No, no. MAIN followed by A. Main A. Function name may be main A. Function name may be main AB. Variable name may be main AB. I want longest matching. I want longest matching. So main, I cannot say main is the longest one. Main followed by A can be variable name. Main followed by ABC, variable name. Main followed by XYZ, variable name. So I cannot give guarantee. When you cannot give guarantee, continue further. When you cannot give guarantee, continue further. I continued. Listen, I continued. Bracket came. Please help me. Bracket came. Bracket came. I want answer from all of you. Main followed by, listen, main followed by bracket. Main followed by bracket. Can you help me now? Until here token. Until here, listen, until here token. Only close, only open bracket. Only open bracket. Is it token? Only open. See this one. Main is a token. Okay. Open bracket. Only open bracket. Suppose only open bracket. Is it token? Of course. Only open bracket. Of course, it is a token. Bracket. Only open bracket token. Try to understand. Only open bracket token. Everyone try to understand. Only open bracket token. Now understand. See this one. Main is a token. Open bracket also token. Combinedly is not a token. Because see this one. If anyone say it is a function, function name main only, not main bracket. Main bracket is not a function. Careful everyone. Main bracket is not a function name. Simply main is a function name. So combinedly not token. If anyone asks you what is the function name, I will say main only. Main bracket is not a function. Main is a function. Main bracket is not a function. So what I mean to say is individually token, combinedly not token. So whenever combinedly not token, so previous one only token. See, combinedly not token, previous one only token. So here, see this one. Here, see, token found. Can you help to found your token? You read the extra character or not? Token found. What is the token? Main. What is the token? Main. So main is which type of token? Identifier. Token found. So token is main, which is identifier. Remember, function name is not main bracket. Function name is main only. Main bracket is not a function name. Function name is main only. Now I want answer from you. You read one character. Listen, you read one character open bracket. Can you see this one? You read one character open bracket. Everyone understand. You read one character open bracket. Is open bracket you added in the main? You read one character open bracket. You added in the main? No, I am not able to add. I read one extra character. Can I add in the previous token? No. If you cannot add a previous token, can you ignore? To identify the token, I read open bracket. Open bracket is not part of the main. So in the previous token, open bracket is not there. You read already. You try to keep in the previous one. It is not working. Then can I ignore now? Please help me. Can I ignore? Hello? Can I ignore? I thought of adding open bracket to main. But main saying that main only token. Main open bracket is not a token. So I read extra. Can I ignore? No, I cannot ignore. Can I take it as a next token? Remember, next token will start from open bracket. If possible, in the current token, I will add. If not possible, in the next token, I will add. Suppose really not required, I will ignore. See, previously blank is ignored. Sometimes, see this one, sometimes the extra character what you read, you have to ignore. Sometimes the extra character what you read, that will be part of the next token. The extra character what you read, because of you have dilemma, you are reading more. The one which you read more, sometimes you have to ignore. If it is a gap cannot be a token. Try to understand. So if it is a gap, extra character what I read is a gap, so you can ignore. Next one, extra character what I read is a open bracket. So I tried to add this person in the previous token, but not required. So this is not blank also. I cannot ignore. So extra character, sometimes you have to ignore. Extra character, sometimes you have to add in the previous token, main only, but not possible now. Now, whenever you cannot ignore, you cannot add in the previous one, you can try for the next one. Right? Fine. So now what you do is, listen, open bracket is a one token. Open bracket is a one token. Remember, open bracket, there is no requirement of any, right, any dilemma. Open bracket, no dilemma. Closed bracket also, no dilemma. So open bracket, one token. Closed bracket, one token. See, closed bracket, one token. Open bracket, one token. All possibilities are there. Try to understand all possibilities. Open bracket, one token. Closed bracket, one token. Every possibility. That is the meaning of finite automata. You are using finite automata. Finite automata will cover every possibility. On starting state, every possibility. Starting state A also there. On starting state A can come. On starting state B can come. On starting state open bracket can come. On starting state closed bracket can come. All people can come. Every possibility will be covered. Every possibility. So now can you help you know? Till now, how many tokens? Please give answer. Till now, how many tokens? This is one token. This is one token. This is one token. Open bracket. This is one token. Closed bracket. Right? Next one. Next one. See this one. This open bracket 5. This also there. This also there. Every possibility there. Remember, I want longest matching. I want longest matching. Now, one more beautiful question. One more beautiful question. Can you help me now? Now, comment starting or not? Now, comment starting or not? One more beautiful question. Now, comment starting or not? Every possibility will be covered. Every possibility. Every possibility will be covered. Longest matching. Remember only one thing. Tokenization means longest matching. Tokenization means longest matching. Tokenization means longest matching. Just remember that. Every possibility will be covered. So we are using DFA. We are using DFA, not NFA, not finite automata also. DFA we are using. We are using DFA. Remember, tokenization purpose, we are using DFA. DFA means deterministic finite automata. Deterministic finite automata. What is the meaning? On the starting state, A will be there one time only. I will be there one time only. B will be there one time. Means every possibility covered exactly one time. That is called deterministic. Right? On every state, every symbol needed, but exactly one time. Otherwise, dilemma will come. Suppose on the starting state, I means two different behavior. You don't know which one you have to take. So on every state, every symbol, exactly one time. On yes, so A there, B there, C there, everyone will be there, but exactly one time. On S1 also, everyone will be there exactly one time. On S2 also, every possibility will be there exactly one time. That is the reason we are using DFA, deterministic finite automata, which is nothing but a regular expression, which is nothing but a pattern matching. Right? Fine. Now can we help you know? Is comment starting or not? Now give answer. Is comment starting? Please give answer. Is comment starting? Is comment starting now? Why don't you give answer? Why don't you people give answer? Is now comment starting? Check here, comment starting. And one more. Comment is for. Comment is for. Everyone listen. Comment for compiler or user? Comment is for compiler or user? Comment for compiler or user? Comments are for compiler or user? User, na? Now see what happened. Listen, now see what happened. On starting state, careful, on starting state, listen, on starting state, one divide, I will go here. One more divide. Can you help me now? Is it, this means comment or not? Double divide. On starting state, double divide. On starting state, double divide. Comment. Listen, comment. Remember, comment cannot leads to any token. Whenever you got to know it is a comment. See, comment signifies. This indicate comment. On comment anything will come. On comment anything will come. Simply ignore. See, no final state. On comment anything will come. Simply ignore. Until, see this one, until new line character will come. But remember, there is no final state. See, this sigma means everything. Anything will come, simply skip. Anything will come, simply skip. Except null character. Sorry, except new line character. If new line character will come, stop it. But no token, no final state. Double divide. Listen, double divide. Oh, comment. So in the comment area, anything will come, simply loop it. Anything will come, simply loop it. Right? Excluding new line character. Whenever new line character, stop it. But it is not a token. What I mean to say is, simply lexical analyzer will skip it. Whenever it got to know, it's a comment. Right? He will read all of them, simply bypass. It will simply bypass until next line character will come. Until new line character will come. So simply stop it. Again start from starting state. Now observe here. Again start from starting state. Lack of space, I am going here. Can you see this one? Lack of space, I am going here. Everyone observe. There is a plus operator. Let us assume that on the starting state, plus operator. I will go to one new state. So one plus operator came. Listen, one plus operator came. I went to the new state. Please help me. Is token confirmed or dilemma? On the new state, one plus came. Is token confirmed or dilemma? Already one plus over. On the starting state, plus came. One plus already over. Dilemma or confirm? Dilemma. See this one. Dilemma there. Some people are asking, sir, what is the dilemma, sir? Sir, already plus operator. What is the dilemma? Can you see this one? Only plus. Listen. Only plus. Addition. Only plus is addition. Can you help me now? Plus followed by plus. Incrementation. So what I mean to say is, listen, individually token, combinedly also token, longest matching you have to take. Individually token, combinedly also token, take combinedly. So I have to try for longest matching. I will check what is the next one. If the next one also plus operator, then stop. Can you help me now? Now dilemma or no dilemma? Now it is a confirm. Now it is confirm double plus. Now it is confirm double plus. Now it is confirm double plus. Dilemma or no dilemma? Now it is confirmed double plus. Dilemma or no dilemma? No dilemma. See, no dilemma. If no dilemma, you no need to read any extra character. Because there is no triple plus. See, there is no triple plus. Right? Single plus is there. Okay. Double plus also there. Okay. Triple plus is not there. If triple plus there, I could have continued. And one more. To confirm, extra character not required. Already double plus, already token confirm, no dilemma, no need to read extra. So token found. Token found. You may say that, sir, what is the token name? Found okay. What is that token? What is the answer? Incrementation operator. It is an operator. Incrementation. Some people are asking, sir, after single plus equal there. Ready, sir? After single plus equal is there. I think single plus token, equal also token, combinedly also token, plus equal also token. So this is called addition followed by assignment. Individually token, combined also token. If you want C language operator list, you can see. C language operator list you can see. Plus equal also token. Plus equal also token. This is called as addition followed by assignment. Let me write now. Token found. Remember longest matching. Very simple. Yeah, very simple. Token found. Token found. The token is plus equal, which is nothing but addition followed by assignment. Assignment, because equal means assignment. Addition followed by assignment. Addition followed by assignment. Remember longest matching. Everyone try to understand longest matching. Our goal is longest matching. So like that you have to take care. Longest matching. Always remember longest matching. So now come here. Now because of you are really comfortable. Can you see this one? 5 tokens over. 6th token. 7th token. 8th token. 9th token. 10th token. 11th token. 12th token. 13th token. See, remember longest matching. 13th token. 14th token. See this one. 15th token. 16th. 17. 18. 19. 20. Return. 21. 22. 23. 24. 25, 26, 27, 28, 29, 30, 31, 32. Maybe somewhere I done wrong. Can you verify once? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So remember, very simple, Mohit, longest matching. Very simple, longest matching. Understand only one thing, longest matching, nothing there. If you have dilemma, continue further. Sir, some people are asking, sir, sometimes I will read extra character. Yes, you read extra character. If you want, you can just see. After 1 plus, if you observe clearly, clearly observe, after 1 plus, I read 1 more plus. See, I read extra. After 1 plus, I read 1 more plus. So the extra one, whichever I read, right? After combining, I got to know combinedly working. So the extra whatever I read, if possible, current token I will add. That is the one possibility. The extra whatever I read, see, the extra whatever I read, current token I cannot keep. In the next token, I will try. In the next token, see, next token I will try. If not possible to current token, for next token I will keep. Suppose, right? So the extra character, whatever I read, current token I cannot keep, right? Next token also I cannot keep. So sometimes blank. Blank I cannot add in the previous one. Blank I cannot add in the next one. So then you have to ignore. So extra character sometimes you have to ignore. Extra character you have to go in the next token. Extra character, current token itself you can take. These are the possibility. Remember, comment thing you can ignore. Comment things you can ignore. Lexical analyzer, don't bother about comment. Wherever it see comment line, it will skip it. Lexical analyzer will skip the comment lines. Lexical analyzer will skip the comment lines. Are you okay? Lexical analyzer will skip the comment lines. Are you okay? So you can write that point also. So see the first point. Lexical analyzer is the first phase of the compiler, which is also known as scanner. Next one. It divides the given program into meaningful words, which are known as tokens. Okay, that is okay. Can you see the third point? See the third point. Lexical analyzer. Lexical analyzer follows longest matching. To calculate tokens or while calculating tokens. Lexical analyzer follows the longest matching while calculating tokens or while finding tokens. Little bit, one or two doubts may be there, they will be clarified. Don't worry. Lexical analyzer follows longest matching while finding tokens. Next one, fourth one. Lexical analyzer uses DFA to compute tokens. Lexical analyzer uses DFA. DFA means deterministic finite automata. What is the meaning? On every state, every possibility covered once only. On every state, every possibility. See, state S1, A will be there, B will be there, C will be there, open bracket there, closed bracket is there, comma is there, because anything can come at anywhere. On every state, every possibility will come, but one time only. If you keep on the same state, two A's, A means it is going to some state, one more A means going to some other state, I think dilemma will come. Lexical analyzer uses DFA to compute tokens. Right? Until now, I think, in my opinion, everyone is fine. Longest matching. Remember, longest matching. I can add one more thing also. See this one. I am using one more color. Because to me space is not there. One more color I am using. See this one. One more color. On the starting state, see this one. On the starting state, I got less than. So I cannot stop. Because the dilemma is there. Let's go for one more symbol. One more less than. I think a double less than means left shift. Double less than means left shift. Less than, left shift. Token found. Suppose isn't that 1 less than followed by 1 less than followed by equal. So less than equal, it is also token. Less than equal. 1 less than followed by equal, less than equal. 1 less than followed by one more less than, left shift. Listen, 1 less than followed by other. Other means not less than also, not equal also. 1 less than followed by other. Then what is the answer? Stop and say it is also token. It is a less than. It is a less than. Simply less than. The extra whatever you read, it will be used for other purpose. 1 less than followed by less than. So it is going to be left shift. 1 less than followed by equal, less than equal. 1 less than followed by other than these two. Less, all right, the second symbol is not less than, second symbol is not equal. Other, oh, only less than, only less than. This other may be used for next token purpose. If possible, see, extra symbol, whatever I read, anything can happen. Extra symbol, whatever I read, if it is possible, I will add in the previous token. See, right, left shift came. The extra symbol, whatever I read, if possible, I will add to previous token, less than equal. The extra symbol, whatever I read, right, I may try to add to the current one, not possible. Then what you do is, right, what you do is, and for the next token purpose, I may use it. Extra thing, whatever I read, I will store in one variable. I may use for next token purpose. Sometimes it may not be useful for next token also. If it is a blank, I can ignore. Now come to here. Come to here. Listen one interesting thing. Listen one interesting thing. Everyone observe. Everyone observe. Everyone observe here. I am using another color. I am using another color. Yeah, this color I am using. See this one. This color I am using. Everyone see this one. Int is a one token. Okay. Main is a one token. Okay. Do you identify or not? Do you identify or not? This one I read, but it is not a token. What I mean to say is white space character cannot be a token. Blank space character, they cannot be a token. They cannot be a token. So let me write now. Lexical analyzer uses DFA to compute tokens. Fourth point over fifth point. Lexical analyzer. Lexical analyzer eliminates comments. Eliminates comment lines. Means you don't count token. Lexical analyzer eliminates comment lines. Sixth one. Lexical analyzer eliminates white space character. White space character. That means those are blank, tab, white space character. Lexical analyzer eliminates white space characters. Those are I am writing. Tab also. If at all, whenever it is the tab symbol, it will simply ignore. Blank symbol, it will simply ignore. Tab, blank, anything else, something like wherever you see gap kind of thing, it will simply ignore. It will simply ignore. I give the, see, first 2 points are definitions. First 2 points are definitions. Next 4 points are there, right? Main points I written. Longest matching rule you will follow. It uses DFA to compute tokens. Lexical analyzer eliminate comment lines. You don't count. Lexical analyzer eliminate white space character. Tab and blank. Tab and blank. Now are you okay? Now are you okay? Mohit, are you okay now? Mohit, are you okay now? Ella, are you okay now? Ella, are you okay now? Mohit, are you okay now? Check once. Mohit, are you okay or not? Ella, are you okay or not? Any doubt? Definitely tokenization. Tokenization. Further, it will become so easy. Only one problem I done. There may be some dilemma. Only one problem I done. There may be some dilemma. Don't worry. Don't worry. There may be some dilemma. In the next problem, it will be very easy. In the next problem, it will be very easy. Yeah. Can we stop now? Can we stop now? If I take one more, it may go to half an hour. Can we stop now? If I take one more, there is a one more point is there. It may take half an hour. One more small story there. One more small story there. Do you want it? It's up to you. Can I continue or can I stop? It will take approximately 15 to 20 minutes. 15 to 30, I don't know also. Say whatever you say, I will do. Yeah, Ella saying continue. Yeah, listen now. Listen, one small story there. I will say that also will continue. I will say that also. One small thing you listen. Everyone listen. One small thing. One small thing there. With that we can end it. See this. This is the program. This point also you listen. This is the program. Careful, careful everyone. This is the program. This point also catch. Assume that it is a program. Assume it is a program. Right? So initially lexical analyzer at the first place. Initially lexical analyzer at the first place here. Initially lexical analyzer at the first place. Right? Lexical analyzer here. Here. Now understand. See this one. I think when you say parser, parser means syntax analyzer. Parser means syntax analyzer. Yesterday I said to you a rough diagram. Now you will get some clarity. Parser means syntax analyzer. Parser means syntax analyzer. Syntax analyzer means grammar. Grammar. So parser is there at S. Careful everyone. Parser means syntax analyzer. Syntax analyzer purpose is creating a tree using grammar. Using grammar. In the grammar, it is there at the start symbol. In the grammar also start symbol. Like automata, grammar also start symbol. Another way of saying. Automata also having starting state. Grammar also having start symbol. If you write in the normal lines, that is the grammar. If you write in the form of a diagram, that is a finite automata. Don't worry that much. In the automata, anyhow, you will see that. In the automata, grammar, right? Finite automata, all the things, anyhow, you will see. Now listen. Listen, everyone. Syntax analyzer is there in the starting. Syntax analyzer is there at the start symbol. Lexical analyzer is there in the program first place. I'm repeating once again. Syntax analyzer is there in the grammar start symbol. In the grammar, so many symbols are there. At the start symbol, syntax analyzer, because you want to draw the tree. You want to draw the tree. See this one. At the start symbol. Grammar is like this. S goes to. S goes to. There may be a first production. There may be second production. So many productions will be there. S goes to third production. S goes to fourth production. Careful everyone. S goes to fifth production. So like that, so many productions are there. On start symbol, so many production. Now, listen, syntax analyzer want to draw the tree. Syntax analyzer want to draw the tree. Okay. Lexical analyzer want to, listen, lexical analyzer want to generate tokens. Lexical analyzer is there in the program first place. You want to generate tokens. And parser means syntax analyzer. You want to draw the tree, right? For that in the grammar, right? It is there at the start place. In the grammar start place, it is there. But remember, this is the grammar. S contains so many production. I can say 1 crore production, 1 lakh productions are there. So many there. So many productions are there. I cannot write all. So many production. S generating so many. Right? S generating so many productions are there. Let us assume that, and so on 50. Okay. So many are there. Now see what happened. Parser ready to create a parse tree or a syntax tree is there at the start symbol. Lexical analyzer is ready to generate the tokens, everything okay. Now see what happened. Listen, now see what happened. This syntax analyzer who want to create the tree, this syntax analyzer is asking the lexical analyzer, hello lexical analyzer, I want to draw the tree. I don't know out of these many production, which production I have to take, I don't know. Please can you give token to me? By seeing the token, I can select whichever production is suitable. Parser asking the lexical analyzer, so many productions are there, I don't know which one I have to take. Right? You please help me wherever you are at that place. What is the token? Please help me. Now what the lexical analyzer will do is, you will do tokenization. Someone asked the token. Now he will start. See this one. He will start calculating the tokens. You know very well. Until final state will come, you will keep on continue. Let us assume, right? Lexical analyzer initially there, row number 1 is there, column number. Lexical analyzer initially, row number 1, column number 1 initially. Now, whenever parser will say, please give token, because by seeing token, I will decide which production I have to take. When parser asks him, then he will start doing. Let us assume that, right? Let us assume that 13 character he read. Means 13 columns he read. He got to know some token came, some token. Let us assume some ID, something, some token. Then he will inform to parser, hello parser, wherever I am at that place, token is ID. Then what the S will do is, S will ask every person, right? According to the lexical analyzer, the current token is ID. Who can give ID to me? Then fifth person will say that I will give ID to you. Fifth production saying that I have ID. You want ID first place? I have ID. I will give to you. So he will take fifth production. Right? Whatever token came, accordingly he will follow. Fifth production is assume that this is the fifth production. Assume. So ID is came. ID is equal to. Now I am at E now. Everyone listen. Now I am at E now. Be careful. Like yes, so right. So many variables are there in the grammar. E also having so many production. Let us assume that production number 55. Some production number I am giving. Every variable having some production. 56. Every variable having some production. 57. Now see what happened. Very interesting. Now parser will say to lexical analyzer, hello parser, now I am at E. Hello parser, now I am at E. E having so many productions. I don't know which one I have to take. I don't know which production I have to take. Please can you give next token? Then again he will start. So after doing a lot of work, then what happened is he will say, I read until 28 column number. The next token which is coming is, assume, let us assume A plus, assume next token. Then he will say, next token is A plus. All right, he is asking all his productions. Next token according to lexical analyzer A plus. Let us assume A plus. Who will give A plus? Then I think this person saying I will give A plus T. I will give. Then he will take. A plus T. Now it is there in the T. Again this T will ask lexical analyzer. Hello lexical analyzer. Now I am at T now. I don't know which token which production I have to take. Please help me next token. Please help me next token. Let us assume that this row number is over. Now I enter into row number 2. Row number 2, whenever you enter, automatically this will become 0. 1, right? Whenever row number 2 you went, now it will automatically become row number 2, column number 1. From here onwards, again it will start. What I mean to say is indirectly, directly. What I mean to say is indirectly, directly. Everyone observe. What I mean to say is indirectly, directly. This is the excellent statement. This is the excellent statement. Can you see this diagram? This is the excellent statement. Can you see the diagram? See, parser will ask lexical analyzer. I know you will make tokens. I know. I want next token. Can you give? Remember, if parser asks token, then only lexical will create token. Because of he knows creating token, he cannot create directly. When parser will ask lexical, then only he will create. He cannot create his own. No one asking why he will create. No one asking why he will create. No one asking why lexical will create. Parser saying that I want to token because I don't know in the available production which production I have to take. I don't know. Please give next token. Please guide me because you are the person who will see program. I don't see program. Parser saying very clearly to lexical, you are the person who will see the user program. I cannot see the program. I can see only my grammar. Parser saying I have grammar only. Grammar contains so many production. I don't know which production I have to take. Lexical bhaiya, you can see the program. Wherever you are, please give next token because I have so many production. Until unless you show what token needed, I cannot take the production. Please help me to select the productions. You give token, accordingly I will behave. When he asks like that, lexical will say, don't worry, I am doing the token. Wherever I stopped previously, from there onwards, I will find the token. So he computed and he said that next token is this. Based on that, parser will ask the existing grammar. I want this. As of now, token is this. I want this, right? Which one will give? I think 56 saying that I will give. So now listen. 56 saying that I will give A plus T. Okay, fine. I am at T now. So T will ask again. Can you give next token? Let us assume second row, almost like 25 characters are over. I got next token. Let us assume, everyone observe. Let us assume T, B star. Careful, T, B star. Very, very interesting line. T, right? T is asking, can you give next token? T is asking, can you give next token? It is saying B star. Assume. It is giving B star. Assume that. Next token is B star. Assume. Next token is B star. It will ask the T production. It will ask the T. Production number 58. Production number 59. See the answer. Or only one, whatever it is. Don't think much. Just I'm giving some idea. So production number 58. I am at T now. Listen, I am at T now. Parser is at T. Parser asking lexical, can you give next token? He given the next token something like, he given next token. Assume, he given next token star. He given next token star. Hello parser. Parser is saying the lexical analyzer. Hello lexical, can you give next token? Hello lexical, can you give next token? Whenever he will ask hello lexical, can you give next token? He is saying next token is a star. He is saying next token is a star. Then this T is asking. Next token is a star. Who will give? Next token is star. Who will give? Then see only one person there. One person is saying I can give next token. Right? Minus operator. So T is asked the lexical, can you give next token? He is saying that next token is a star. Then when the T will ask the grammar, is there anyone who can give star operator? One person is saying that I cannot give star, I can give minus only. Means according to grammar, minus only possible. But according to lexical, star is required. Lexical saying that in the program, next token is star. According to the grammar, next token is minus.
So you don't know which one it has to take. Then he got to know that grammar cannot be wrong. Wrong is only program. I think this is going to be syntax error. He is expecting minus operator, but he got star operator. Remember, whenever parser will ask the lexical, can you give next token? He is saying next token is star. But when you see the grammar in the T, right, this person saying that I cannot give star operator, I can give only minus operator. So grammar saying that minus possible, program saying that star required. I think in the program something wrong, because grammar cannot be wrong. Grammar cannot be whatever lexical saying. Accordingly, it asked the grammar. All the grammar people are saying that star is not possible. P person saying that star is not possible. Star is not possible. T person saying minus only possible. But program saying that star required. Oh, right? So minus is expected, but unfortunately star is coming. There is a syntax error. Now what the parser will do is, it will go to error handler. You will inform to error handler. Hello, error handler. I am expecting minus operator, but lexical is saying that star operator. I think in the program something wrong is there. In the program something wrong there. Now lexical, now error controller saying that. I'm repeating once again. Parser is saying to the error controller. Parser saying to the error controller, hello error controller, I asked the lexical, please give next token. He is saying star. But I seen my grammar, that grammar saying that next minus only. Grammar saying next minus only, lexical saying that next person is star. Means grammar cannot be wrong. Program only wrong. User may be written wrong story. So minus is expected, but unfortunately star is written. This is the error message. I am the syntax analyzer, right? Syntax error. Error handler, can you note down? There is a syntax error. I am expecting minus, but programmer written star operator. There is a syntax error. Can you note down? Then error handler is saying to the parser, okay, I will note down. You are saying to me, error is there, note down, I will note down. You are a syntax analyzer, you are saying, I will note down it as a syntax error. That is also okay. But what is the error? You are expecting minus, but unfortunately programmer written star. Minus is expected, but star is written. Syntax error. I will note down everything, but right? Lexical analyzer, as of now, where are you? In the program, as of now, where are you? You will say, I am row number 2, column number 25. What is the meaning? Row number 2, column number 25, minus is expected, but star is came, syntax error. You will note down all. Which place, which row you are. Hello, lexical. You are the one who is reading the program. You are the only one who can see the program. From which place you said star is a next token? Please inform me. So you will say, hello error handler. Hello error handler, my name is a lexical analyzer. I am there in the second row, column number 25, right? According to the program, star is expected, but rules are saying that minus is expected. So syntax analyzer is facing the problem. Please note down syntax error, row number 2, column number 25, minus is expected, but star is coming, right? All will cooperate each other. Remember, all will cooperate each other. So you may be thinking, yesterday, this time you are thinking, like first lexical will be done, next to syntax will be done. You may be thinking like that. You may be thinking, first to lexical will be done, right? Next to syntax will be done, next to semantic. No, bhaiya, at a time all will work. In your body, at a time, you are watching with eyes, you are talking with mouth, right? You are writing with hands, you are eating with mouth. How your body all are doing at a time. Compiler also doing same. Lexical, you do tokens. Parser, you create parse tree. Hello, semantic, you do type checking. Now listen, do you believe or not? Do you believe or not? See, do you believe or not? Whenever tree creation is going on, this is a identifier. Listen, this is identifier. Whenever identifier, listen, Whenever identifier came, immediately semantic analyzer will come. Whenever in the tree he is able to see identifier, next token is a identifier. So see this one, like syntax asking lexical, can you give next token? He said next token is ID. Whenever he said next token is ID, immediately semantic will come. Semantic will ask in the symbol table, what is the type of this ID? Type of this particular person in the symbol table, it is a float. But unfortunately, we are doing operation with someone else. Some type mismatch there. He will inform to error handler. Allow error handler. There is a one person, right? Name is this one. His type is this. But as per the rules, both should be same type. But his type is something else. There is a type mismatch error. Can you check? What I mean to say is all will work together. All will work together. Try to understand. Now I am writing one very, very important point. Can you see this one? Seventh point I am writing. Can you see this one? Seventh point I am writing. It's a very, very important one. Seventh point I am writing. Lexical analyzer. Helps error handler. Lexical analyzer helps error handler by providing row number, column number. Row number, column number. Lexical analyzer helps error handler by providing row number, column number. Lexical analyzer helps error handler by providing row number. Remember, you may say that. Why he won't be providing? He only can see the program. Other people cannot see the program. He only see the program. Other people cannot see the program. Whenever there is a issue, error handler will ask the lexical. Hello, lexical, where are you? I am there in the row number 2, column number 25. Again, semantic also got problem. Let us assume that somewhere semantic got problem. You will inform to error handler. Error handler, I am a semantic analyzer. Right? At this place, I got a problem. Then immediately, error handler will ask the lexical. Lexical in the program, where are you? In the program, I am there in the row number 75, column number 13. Row number 75, column number 13, I am. So then immediately, right? Immediately, error handler will note down, right? So there is a semantic error at the row number 75, column number 13, you will note down. Everything will be note down after compilation is over. Whatever you note down, you will print as it is. Whatever you note down, you will print out as it is. What I mean to say is, lexical will do tokens if needed, not whatever you want, not whenever you want. Lexical will do tokens if needed. Parser will create parse tree. Whenever parser creating parse tree, right, you don't know which production you have to take. By seeing program, you have to create the tree. So by seeing program, but he cannot see the program. So let's ask the lexical. Hello, lexical, you can read the program, na? You read. Lexical, you read program. So he's reading. Then he will give token. Based on the token, parser will create a parse tree. Suppose parse tree creation not possible, he will inform to error handler. Whatever tokens he is giving, I am trying to create the tree, but unfortunately tree not possible. So lexical, right? Error controller, please note down. You will note down and right, all the things will be done. So remember all these 7 points. This class happened today so nicely. So nicely. Sometimes I will plan somehow my class. It may not go as I planned. Today it went so beautifully. This class went. Thank you so much for your cooperation. Actually, I want to stop. 15 minutes back, I want to stop. You only said to me, continue. So that is the reason I continued. That is the reason I continued. That is the reason I continued. Is it okay now? Bro, Mohit bro, is it okay? 7th point is okay. 7th point is okay. Ella, are you okay? Mohit, are you okay? Nidhi, are you okay? Kittu Bhaiya came. Are Kittu, are you visiting professor? You didn't came starting. You are EPT visiting professor or what? Are you EPT visiting professor? This Nidhi also came today only. Are you also visiting professor? Nidhi Bhaiya, Kittu Bhaiya, are you visiting professors? Kittu Bhaiya and Nidhi Bhaiya, are you visiting professors क्या? एक दिन आएगा, दूसरा दिन नहीं आएगा. Okay, fine. So last point is very important. Last point very important. What is that one? Parser want to create parse tree. So parser want to create parse tree. So many production. You don't know which production you have to take. Without seeing program, you cannot take the production blindly. So you will ask Lexical. Hello Lexical, you can see program, na? See program and let me know where are you, what is there in your area, what is there in your area, ID there, let me know. Then as soon as you will say ID there, immediately will ask all the people, all the productions you will ask, who will give ID to me? If anyone say I will give, you will take. If anyone say we cannot give, as per the program ID required, but unfortunately no one is giving, it will simply inform to error handler, right? Lexical saying something where grammar is not able to give. Grammar don't have any problem. Problem is with the program only. So I think in the program, wherever program is now, wherever Lexical is there now, in that area some problem there. Hello error handler, please take care. Error handler will contact all the people. Hello Lexical, where are you? Second row, 25 column. Hello syntax analyzer, what is your problem? I am expecting plus, but he is saying star. Right, then you will write down all. Syntax error, row number 2, column number 25, minus is expected, but unfortunately star came. Same thing happened with the semantic also. See, semantic is there somehow here. Semantic is there somehow here. You will see the symbol table. What is this ID? What is this ID type? This ID type is expected float, but unfortunately it is integer. Let us assume conversion is not possible. So you will write error message. Row number 2, column number 25, right? I am expected the into, unfortunately float there. There is a type mismatch error. There is an undeclared variable. There is a multiple declaration. Now it is a correct time. 8th point I am writing. Lexical, syntax, semantic. They will scan the program in 3 rounds or 1 round. Lexical, syntax, semantics. These 3 people will scan the program in 1 round or many rounds. They will scan the program in 1 round or many rounds. All the 3 people will scan the program 1 time or many time. Oh, Nidhi, all these 3 people will scan the program 1 time or many time. Mohit, that program will be scanned by 1 time or many time. Program scanned by all these 3 people 1 time or many time. Many time. Are one scan na? All 3 people are working together. All 3 people are working together na? Are 1 time na? How can you say many? Are gootle? How can you say many? Can you see this? Can you see this one? Can you see this one? Lexical only will scan. See, lexical only will scan. All the people combinedly working. See, semantic also working, syntax also working, lexical. All three people are cooperating each other. All three people are cooperating each other. So lexical will say, take this token and do. Syntax will say, can you give token? Semantic will say, can you give type? All cooperating each other. So can you help me now? If all things can be done in one time, why are you doing multiple time? If all can be done at a time, why are you doing multiple time? So remember, one scan only. See, total program will be scanned once only. Whenever needed, they will ask the token. So it is keep on giving token. See, one time only scan. See, one time only scan. Program will be scanned one time. These people all saying many. Not one person, two person. All saying one. All saying many. If you really want to go to dinner, go. Don't say whatever wrong you want. This many concept started by Kittu, I think. This Kittu person started many. Everyone said many. Everyone said many. If see this one, if all are not, listen, if all are not cooperating each other, then many. If all are not cooperating each other, then many rounds. They all are cooperating. Right? Lexical will do tokens, parser will create parse tree, semantic will do type checking. All these three people are doing their work. Right? Fine. Now let me write. I will write that point also. Maybe misunderstanding, I can understand. Let me write the 8 points. See this one. Program will be scanned only once. Program will be scanned only once by all these 3 phases. So once, right? Only once means one scan. Only once means one scan. Order of end time. One time scanning the program. Program starting to program ending. One time scanning, because all 3 are cooperating each other. Whenever anyone asks, give next token, he will give next token until total program is over. He will keep on giving token. One scan only. Suppose all 3 are doing separately, na? Lexical order of n, one scan. Syntax also one more scan order of n. Semantic also one more scan order of n. That time 3n. Unnecessarily time will waste. Really one time not possible, then go multiple times. One time possible. Lexical order of n, semantic order of n, syntax order of n, totally 3n, but it can be done in one scan only. So one scan is enough, order of n. Right? Fine. So one time you revise, one time all the people revise, in the next class, how many tokens are there? We'll see. One problem only I done. Token counting, one problem only. You may be having many doubts in the token counting. Today, theoretical concept. Today we are discussing something about the theoretical thing. In the next class, right, approximately 10 problems will come. Right? Someone is saying that Kittu is saying the best case is order of n. Every case order of n. Kittu, every case. Because you have to scan once. Not more than one, not less than one. One time you have to scan. Every case is n. One time just scan. One time scan, while scanning is going on, everyone will do their part. In the next class, we will see 10 problems. And one more thing I want to say to all of you. One nice offer is going on, 80% discount going on. 80% discount going on. So remember, within few days, this 80% become 20% or 30%. I am able to hear sales people are talking in the meeting. So I am able to remember those. I am able to listen. They are planning next to 20% or 30%. Only this much discount. So you will be troubled a lot within 2 days. Within 2 days, right? This offer will be changed from 80% to 20% or 30%. You will be definitely maximum losing side. My suggestion is, if you are serious, please buy now. If you are serious, please buy now. Use the code EPT 595 ARJ. Use this code and buy now, 80% discount. If you buy after 2 or 3 days, because of Raksha Bandhan, they given the 80% discount. After Raksha Bandhan is over, they will give 20% or 30%. You will be in the losing side. When RIC will start, first cry for this, right? First cry this, right? After the subject is over, RIC will start. After the subject is over, RIC will start. This subject will be over, in my opinion, maybe 20, around 20 it will be over. After 21st onwards, RIC will start. 21st onwards, RIC will start. Right? Fine. Thanks everyone. See you in the next class. Thank you all. Good night.